Hello guys, this video is to show you how to simplify rational expressions. In this case here, I'm going to show you a couple of examples. We'll focus on the first line you see here, this first line, because this is what we're going to use to simplify the rational exponents. But I put those here as more just to refresh your mind if you forgot. B to the power of -1 is equal to 1 over b to the nth. So you flip the base here, or you can write it as 1 over b to the n, because 1 raised to any power is the same 1, okay? Then a to the power of b raised to the power of -2, negative n in this case, is equal to b over a to the power of n. So you flip the base, a becomes, the numerator becomes the denominator here, the denominator becomes the numerator here. And remember, you change the sign of n, the exponent. It becomes positive, so that's why you flip it, okay? Then once it's written like this, you can put it as b to the n over n to the a to the n. Anything raised to the power of 0 is 1. I have to make an exception here. Except 0 to the power of 0. So assuming that b is not equal, let me erase this. Assuming that b is not equal to 0, okay? Because when b is 0, the answer is indeterminate. It's not 1, okay? So remember that. Okay, all right. Now let's go ahead and solve some problems, simplify some expressions, just for this to make sense to you. So I'm going to erase the more. These three I put here for you, and I'm gonna keep this because that's what I'm gonna use to explain what I'm gonna do here. Okay, so I'll take a very easy example to start. Let's say for number 1 here, example 1. And they would tell you to simplify, by the way. You would have to simplify. And if I have for number 1 here, if I have 4 to the power of 1/2, for example, this, I would just need to use the formula I have here. So it would be nth root, which is 2. So I'll put the square root. You don't have to put the 2, but I'm putting it here just to show you that I'm using the n as the 2. So I'll put the base here as the radicand now, and the answer raised to the power of 1, okay? And at the end, it's just the square root of 4, which is 2 to the power of 1, which is 2, okay? That's it. So this is what you do to simplify. But you gotta be careful. You gotta be careful if we have signs involved, okay? So let's do 2, the second one, because I'm gonna do a couple just to make sure you get this. Okay, let's say we have -16. So -16 and everything raised to the 3/4, okay? Now for this one, again, remember where to put the base. The base is -16 because we have everything between parentheses here. And I have a radical here. The root is 4, the index I'm saying. Then it's raised to the m, which is 3 in this case. I'm using this, okay? All right. Now, it's what? It's the 4th root of a negative number. Now, remember, in this case here, if you have a negative radicand, remember what I actually explained this in another video of mine. Now, I said if the index is even, the radicand must be non-negative. Okay, so it could be 0, it could be a positive number, but not negative. Okay, so in this case here, since it's negative, you know that this will not be a real number. Okay, so you can stop here and say not a real number. This would give you an imaginary number, but not a real number. Okay, that's it for this one. Now, let's try another one. What if it was, let's say number 3 as another example to simplify. Let's say for 3 here, if we have 16 to the power of -3 over 4. Well, we learned that this is the base, but we learned that we can actually flip what we have here and write it as, because it's a negative exponent, we can write it as 1 over 16 to the power of 3/4. And this will be 1 over 16 is the base, so I'll put it as the radicand, 16. And the index here will be 4. And the exponent here, I'll put it as 3, the m outside here, okay? Then we keep going like this, all right? So now we have 1 over, the fourth root of 16 is 2, because 2 times 2 times 2 times 2, 4 times, right, is 16. So the answer here is 2 to the third, which is 1 over 8, okay? So remember those steps. This is it here, 1 over 8. Now let's try another one, okay? Number 4. Number 4. So for number 4 here, let's say you have negative 16 to the power of negative 3/4, okay? One thing to know here is that the negative 3/4 does not affect the -1 or negative sign that's here, because there's no parenthesis here. In other words, whatever you do, keep that guy outside, because it's not part of what you're doing, because the exponent does not affect it, okay? So that's why what you have here, you can just like I said previously, you can just put 1 over 16 to the 3/4, okay? 1 over 16 to the 3/4, okay? The negative sign is still there. Be careful. Now I'm keeping my negative sign, and I'll have again 1 over the fourth root, the base 16 raised to the power of 3, okay? Again, my negative sign is outside. This will be fourth root of 16, 1 over 2 cubed, which is negative 1 over 8, because 2 times 2 times 2 is 8. So negative 1 over 8, okay? Another one, after this one, let's try another one, 5. As you can see, I'm using the same numbers but different signs, just to make sure you see the difference, okay? So let's go with 5. So you see, I can just change something, just a sign, and the answer will be different, right? So let's go now with 5, number 5. I'll go with negative 16 raised to the power of negative 3/4. Okay? So now this will be affected by the exponent. So I'll have 1 over, okay, negative 16 to the positive 3/4. Okay? Now, using the formula I have up there, the rule there you have, so it's 1 over the fourth root of negative 16, which is the base, and everything raised to the third power, right? Again, from here, we have a problem because we have an even index and a non-negative radical. So this is not a real number. Okay? So this is what I had for you, just for you to know how to play around with rational exponents. Okay? Very important. Thank you.